Welcome to a new lesson, secondary sort. In this lesson, we would learn another technique that can be applied to problem scenarios. There can be a problem scenario where you would like the output key group result to be sorted by a value and not just by the key. The idea is that you want the order of values to be stable with the consecutive runs, which in general doesn't happen. This kind of technique where we require to have values in the ordered form is technically termed as a case of secondary sort. Let us understand this with an example. Suppose we have an input record with year, month, and the maximum temperature recorded in that month. The ultimate objective of our problem is to feed in the reducer with the data in the form that the records are arranged in the descending order on the basis of the temperature value. We can use this input feed at the reduced phase and design the reducer just to emit the first occurrence, which produces the output of the maximum temperature for that year. Though this is not a recommended approach to find the maximum temperature, but to understand the concept of secondary sort, we would design our solution to this approach. The more recommended approach is to simply treat year as the key and not worry about the sorting of values and have logic of finding the maximum temperature at the reduced phase. But of course, we are here to understand a new concept. So the challenge is, what should be your key value pairs at the map phase, and how are you going to make the map output so that you get the values ordered by temperature in the input to the reducer? This input to reducer is shown just as a guideline. You can of course change it in your solution. Although the complete theory behind the approach hasn't been covered yet, but still I would ask you to give it a little thought to it. Pause the video now and give it a think for a minute. Let's look at the approach. I'm pretty sure that you would have considered combination of year and the temperature as the key and the whole record as value. Even if you were close to this approach but not certain, please accept my congratulations. You were on the right path. So now the input to reducer would look like as shown. Here the keys would be the combination of year and temperature, and value would be record. But what happens in this case is that another record 1900,9, the key would have a different hash code as for the previous record with the key 1900,11. And so these two records would go to two different reducers instead of the same reducer. This would not be a good case for us. So in this case, we learn a new concept of composite keys. Composite key is composed of two portions: natural keys and natural values. Natural key is the portion of composite key which should be considered for partitioning and grouping, and whereas natural key is the portion of the composite key which can be considered while sorting. So in this case, the solution would require to implement the following. First step is to make custom writable class in order to handle the composite key. Composite key would always be made up of two or more Hadoop data types. In this case, it would be a pair of int writables. While writing a custom writable, you need to override a few basic set of functions which are used by the MapReduce framework to read, write, compare, hash, and convert the object to strings. Second thing we need to do is tell Hadoop how to compare the custom variables while performing the sort. We would do this by using the function job.setSortComparator class. In this function, we would pass a custom implementation of writable comparable and override its compare method to help Hadoop understand which custom key is smaller than the other when compared. For example, in this case, 1900,9 would have to come earlier than 1900,11 record in case if we were to arrange the record with ascending order of temperature. So in the compare function of setSortComparator class, we'll have to have write logic that compares the first part of the composite key field and then considers the second part of the composite key field to find the order. Then comes the custom partitioner. This would be required by Hadoop to correctly identify to which partition the record belongs to. We'll have to override the getPartition function in this, and it is always the natural key portion of the composite key which would decide the partitioner. Lastly, we need to tell Hadoop that by which field it needs to group and feed the input to reducer. So for this as well, natural key portion of the composite key would be the grouping field. In this case, it's the year. So in short, to design such a solution, you need to determine the composite key and value and perform these 4 steps, which would vary slightly in different versions of Hadoop, but the overall idea would remain the same. It is just to tell Hadoop how to sort, partition, and group the composite keys.